Page 83. Basic nature of matter. Recap, Section A. Matter is anything that has mass and takes up space. Matter is made of very small particles called atoms. Atoms are constantly in motion. They move faster at higher temperatures. Matter exists in three common states or phases, such as solid, liquid, and gas. Gas. The particles of a gas move fast enough to overcome most of the traction forces between them. Therefore, a gas has neither a definite shape nor a definite volume. It expands to fill any container in which it's placed. As thermal energy is taken away from its gas, its molecules slow down, and condensation takes place when a gas becomes liquid. As thermal energy is added to a liquid, the molecules have enough energy to overcome that force holding them together. The process of changing from liquid to gas is vaporization. So as you can see, from condensation, we're going from gas to liquid. For vaporization, we're going from liquid to gas. And the arrows on the side match the movement. The second phase of matter is liquid. The particles of a liquid vibrate fast enough to overcome some of the attraction forces between them. This allows them to slide past one another, which gives a liquid a definite volume but no definite shape. A liquid takes the shape of its container. As thermal energy is removed from a liquid, the molecules slow to the point that they have only enough energy to vibrate in a fixed position. This change from liquid to solid is called freezing. On the other hand, as thermal energy is added to a solid, its molecules begin to vibrate more rapidly until they break out of their fixed position. At this point, the solid becomes a liquid. The change from a solid to a liquid, so solid to a liquid, is called melting. The third state of matter is solid. Particles in a solid are strongly attracted to one another. They vibrate at about a fixed position. This gives a solid both a definite volume and a definite shape. Matter may also exist in a fourth phase, called plasma. When a gas is heated to a temperature above 10,000 degrees Celsius, atoms start to break apart. At such high temperatures, the electrons are removed from atoms, so plasma is made of ions and electrons. The Sun and most of the rest of the known universe is in the plasma phase. On Earth, plasma can be found in auroras, flames, and lightning. Section B. Matter forms all substances. A substance may be classified as an element, a compound, or a mixture. An element is a pure substance that has its own unique type of atom. For example, an oxygen, carbon, or hydrogen atom. The atoms of any element are alike, but are different from atoms of other elements by the number of protons in the nucleus. Compound. A compound is a pure substance that consists of atoms of two or more elements chemically bonded in a fixed ratio, such as H2O, C6H12O6. The smallest particle of a compound is a molecule. Compounds can only be separated into the elements from which they are made by a chemical process. Compounds are classified as either organic or inorganic. Organic compounds contain carbon and are, or once were, part of a living thing. Mixture. A mixture consists of two or more substances that are not chemically combined, such as sand and salt, or water and sugar. The different substances in a mixture can be separated by some physical means. Section C. Acids, bases, and salts are three common groups of compounds. Acids produce hydrogen ions when dissolved in water. Acids taste sour, corrode metals, and conduct electricity. Examples are citrus juice and vinegar. Bases produce hydroxide ions in a solution. Bases taste bitter, feel slippery, corrode metals, and conduct electricity. Soaps, cleaning products, and baking soda are bases. The pH scale measures the concentration of hydrogen ions in a solution. A solution with a pH greater than 7 is basic. Acids have a pH of less than 7. A pH of 7 means the solution is neutral, neither acidic nor basic. Pure water is neutral. A salt is an ionic compound formed when an acid reacts with a base. The reaction is called neutralization. Water is also a product of this type of reaction. For example, when hydrochloric acid, HCl, neutralizes sodium hydroxide, NaOH, table salt, NaCl, and water, H2O, are the products. This is shown in the chemical equation below. Section D. Physical properties, characteristics, are used to describe matter. A physical property is defined as any characteristic of a material that can be observed without changing the identity of the material itself. Physical properties include shape, density, solubility, odor, melting point, boiling point, and color. Some physical properties are unique to a pure substance, or element or compound, and can be used to identify an unknown sample of matter. These are characteristic properties. The characteristic properties of a substance are the same no matter the size of the sample. Density is an example of a characteristic property. Density is defined as the mass per unit volume of a substance. The mass and the volume of a substance must be measured to determine density. It is calculated using the formula density equals mass over volume, where D stands for density, M stands for mass, and V stands for volume. The standard unit of density is grams per cubic centimeter for solids and grams per milliliter for liquids. Another example of a characteristic property is solubility. A solution is a mixture that appears to be a single substance. The different kinds of particles in a solution are distributed evenly. Solubility is defined as the maximum amount of a solute that can be dissolved into a certain amount of solvent at a specific temperature and pressure. A saturated solution is formed when a solvent has dissolved as much solute as it can in a specific temperature. So for example, if I wanted to make hot chocolate, I would take my solute, which would be the hot chocolate powder, and I'd pour it into water or milk, which would be my solvent. And if I added just the right amount, it would be delicious. However, if I add too much, then it's going to mess with the solubility of that powder. Solubility is expressed as the number of grams of solute which can dissolve in 100 grams of solvent at a specific temperature and pressure. The solubility of a substance may be increased by raising the temperature of the solvent, which is why when I make hot chocolate, I always heat up my water first so that I can increase the solubility of the powder. A solubility graph shows the relationship between solubility and temperature for a given solute in 100 milliliters of solvent. Stirring or reducing the particle size will speed up the dissolving process, but neither will affect solubility. This means that crushing a solid into smaller pieces will reduce the time it takes to dissolve, but will not increase the overall amount that will dissolve at a given temperature. Some other characteristic properties are melting point, freezing point, and boiling point. Melting point is the temperature at which a substance changes from a solid to a liquid as thermal energy is added at standard atmospheric pressure. Freezing point is the temperature at which a substance changes from a liquid to a solid when thermal energy is being removed. For any given substance, the freezing point and melting point are the same temperature. Boiling point is the temperature at which a substance changes from a liquid state to a gas as thermal energy is added at standard pressure. Section E. A chemical property describes a substance's ability to be involved in a chemical reaction to produce a new substance, or chemical change with different properties. Combustibility, or flammability, is the ability of a substance to ignite and burn, to combine with oxygen at a rapid rate in such a way as to give off heat, gases, and usually light. Reactivity describes a substance's tendency to undergo chemical changes to produce a new substance. Acidity and basicity are chemical properties which describe a substance's ability to undergo a neutralization reaction. This concludes the basic nature of matter section.